Hi, my name is Dr. Kevin Windisch, and I'm a general pediatrician living somewhere in the southwest of the United States. I've done a bunch of videos over the years on topics about pediatric medicine, healthcare for children, and healthcare in general. Some for people in graduate school, some for doctors and people in training, and some for patients. My son, who's quite a bit younger, has asked that I start to do a video on a very different topic, or a video series on a very different topic. So today we're going to sort of branch off into that. And that topic is a topic that causes a lot of stress for a lot of young people in school, and that topic is algebra. Now, algebra, for those of you who don't know anything about it, is often the first time that young people actually start to learn real mathematics. Prior to that, all you're learning is arithmetic. And there's nothing prior to algebra that can't be done on a calculator. Once you get into algebra, you actually start getting into the field of mathematics where you actually have to understand numbers and learn number theory and learn how to manipulate numbers. And that's a bit of a leap for a lot of people, and it stresses them out. Plus, they hear a bunch of stories about algebra, and it scares them. So many times in my life, because I've tutored algebra off and on since I was in high school, I've heard people say, well, when am I ever going to use this in my real life? And my answer, even today, is, what days do I not use algebra? I use the concepts every single day. So when you get good at it, it becomes a very powerful tool that you're going to use for the rest of your life. So what exactly is algebra? Well, it was invented in the 9th century, so that's about 800, somewhere around 800, 850 AD. At that time, Europe was in the middle of the Dark Ages. There were no really big kings. All of the big countries like the Holy Roman Empire had been destroyed, and most people couldn't read or write. But in Baghdad, Persia, I guess that's actually Arabia, Baghdad, Arabia, there arose a mathematician whose name I really can't pronounce, I'm not even going to try. And he wrote a book called Hisab al-Jabr. And that roughly translates into, I don't even know what it translates into, but it got translated into Latin, found its way across Europe, and by the 11th century, so it took 200 years. Well, yeah, 200 years to spread from Baghdad to Europe. But at that point in time, the mathematicians and scientists finally had a system of numbers that became useful to them and allowed them to start solving some of the questions that had puzzled scientists going back to 500 BC in ancient Greece. So, understanding where it comes from, let's now begin to look at it. The good news is this: since first grade, you've done a certain amount of algebra. You just didn't know it, because we didn't tell you you were doing it. And we didn't tell you because nobody wanted to scare you, and because some of your first grade teachers themselves were scared of algebra, so they don't want to put that scary name on it because that frightens them. The fact is, you've been doing this since you could count to 10. So let's take a look at that. So I'm going to have my videographer here center on the paper. So get a good zoom in on the paper. Can you see the paper?
Yes, sir.
So here's a question you've been dealing with since first grade. 3 plus what equals 5? And the answer is 2, because we know that 3 plus 2 is 5. When you got to second grade, they got really tricky, and they gave you 6 minus what is 4. And then, to really challenge you, they would give you, something minus 3 equals 9. And you knew that 6 minus something is 4 was 2, because 6 minus 2 is 4. And you knew that something minus 3 was 9, was 12 minus 3 is 9. In 3rd grade, they started teaching you multiplication and times tables, and they taught you that something times 3 is 18, and you knew that that something was 6, because 6 times 3 is 18. And then in 4th and 5th grade, they gave you 8 divided by something is 4, and you knew that that answer was 2, because 8 divided by 2 is 4. And then they got really tricky, and they gave you 16 divided by, they gave you 18 divided by, sorry, I'm having a tough go of it. Something divided by 5 is 5, and you had to know that that something was 25, because 25 divided by 5 was 5. Okay, this is algebra. But the first step we do in algebra is we get rid of this question mark, because question marks are really hard to work with, they're really hard to draw, and you can't add and subtract question marks together, because what's a question mark plus a question mark? It just doesn't work, all right? So we replace those instead with letters. And those letters can come from any alphabet that you want. They don't have to come from the English alphabet.
Lambda.
So, well, we'll come to those then, but often we start with English letters. So to just change this first one into an equation that we would see in algebra, we'd get rid of the question mark and we'd replace it with a letter. So 3 plus, and you can pick your letter from any alphabet you want. Going back to some stuff you learned in around 5th grade, however, the one letter I'd recommend you not use is the Greek letter pi, because pi always represents 3.14, or approximately 3.14. So I wouldn't use pi. I wouldn't use the Greek letter pi, but use anything else you want. All right, a popular one is the letter n. 3 plus the letter n equals 5. N in this equation would be 2, because 3 plus 2 is 5. Here, in this equation, we could choose to replace the question mark with a different letter. Maybe I want to replace it with the Greek letter lambda. So 6 divided by lambda equals 4. Oops, not 4, equals 3. Lambda would have to then equal 2. All right, and I could use Hebrew letters, and I can use, pick your letters. And in science we do. We work, depending on your field of science, we use all sorts of different lettering. And sometimes we play around with the letters. So we take English letters and then we change them. So we have H and we have H bar. H bar is a very specific, in physics, H bar is a very specific variable, or stands for a very specific number, but sometimes we just use H bar. Sometimes we'll use, put a little symbol after the letter, so N0 or N0, and N1 and N2, just so we can have a lot of different N's. Just lots of ways of writing something that simply means we don't know what this is for right now. Okay? So that's the first lesson in algebra. So as you work through this, then some problems you can solve at home is 5 plus an unknown is 7. 9 plus an unknown is minus 2. Now you already should know how to do positive and negatives if you're learning algebra. If you don't know how to do that, we can go back and do a lesson in positive and negatives, but we expect you already know how to do this because this is taught in pre-algebra. 8 minus 2 plus an unknown is 12. Okay, so these are some simple 6, and in algebra we get rid of the times symbol being an x because that's confusing. We just said we start substituting in letters for unknowns, and an x is a really common one that we use as an unknown because we use paired unknowns in a lot of equations, x and y. So whenever you see an x, people think it's the variable x, not a time sign. So we're going to get rid of that x. We're going to replace it with either a big fat dot, so 6 times 2, or, because that can be confusing because people think it's a decimal 6 and 2/10. All right, or we'll replace it with parenthesis, 6 times 2, or 6 times 2. All right, or when we're multiplying a variable, we just get rid of the symbol altogether and we write 2n for 2 times n. All right, so that's the same thing as this, or just 2n. All right, so 6 times 2 times z equals 5.2. We also get rid of the division symbol. Too difficult to draw, too difficult to work with. We replace it with a fraction bar. So 9 plus 2 divided by an unknown. And we're starting to get into advanced equations. Let's not do that right now. 3 divided by an unknown is 9. You should be able to answer that one. All right, so we'll work these two together, or work these through together. So this is an opportunity to pause this, work through these equations, and make sure you actually know how to do them. All right, and then when you're ready, restart the video at this point. 5 plus an unknown is 7. Well, 5 plus 2 gives you 7. Right now, you should be able to just do this in your head. Later, we'll be able to solve more complicated equations. 9 plus an unknown is minus 2. That unknown needs to be a very large negative number, and it would have to be minus 11, because 9 minus 11 is minus 2, because if you have 9 marbles and I take 11 away, I take all 9 of your marbles, and you still owe me 2 more. 6 times 2 times z equals 5.2, and for this one I would actually need a calculator. 6 times 2 is 12. 12 times z equals 5.2. This is a more complicated equation that you're going to learn to solve later, and if you couldn't figure this one out, don't feel too terribly bad about it. But what you're going to do is you're going to divide 12 from both sides, and that'll get you z equals 5.2 divided by 12. All right, and you need a calculator for that one. I don't know what the answer is. Plug it into a calculator. I don't really care what the number is. I'm interested in the process. 3 divided by something is 9. Ooh, that means the number got bigger when you divided, which means you had to divide by a fraction. 3 divided by a third is 9, because 3 over 1, remember when you divide by a fraction you multiply by its reciprocal, times 3 over 1 is 9. Alright, that is your first lesson in algebra. Right, the second lesson in algebra, don't pause it yet, I'm going to go into the second lesson because this works at the same time, is known as the substitution principle. If something equals something else, then anywhere you see that first thing, you can substitute the second thing. So if I say that n equals 5, anywhere I see an n, I can put in the number 5. So if I have an equation, n times 2 equals what? And I know that n equals 5. Anywhere I see an n, I can put in the 5. 2 times 5 is 10. If I say that theta, which is a Greek letter, equals 1/2, and I say we have 2 2 pi theta, and I say, what's theta equal? Or what's the equation equal? Anywhere I see a theta, I put in 1/2. 2 times the Greek letter pi times 1/2. 2 times 1/2 is 1. 1 times anything is itself. So 1 times pi is pi. And in algebra, we usually don't turn pi into 3.14 because that's just an approximation. We just talk about it and call it pi. And we leave it there. It's only when you get into physics or or chemistry where you have to then generate a number that you can weigh on a scale that you substitute in some approximation for pi. And depending on how accurate you have to and how precise you have to be, you might not use 3.14. You might use, 5, 6, 7, 27 digits out. And there's actually a book where you would, in the old days, we looked it up in a book called the CRC Handbook of Chemistry and Physics. And it just took pi out, 6 pages long, and you just kept writing until you got enough digits. Now you look it up on Google, but depending on what you're doing, you might need more decimal points. Because remember, pi never repeats, and it's its own number. All right. So another one you might be asked to answer would be 2 times n plus 3 is what, if we know that n is equal to 6. So you have 2 times 6 plus 3 is equal to something. Remember your order of operations from pre-algebra? What's that order of operations, Ben?
It is PEMDAS. You do parentheses, exponents, multiplication, and division at the same time, then addition and subtraction, and if you have two of the same category, you work left to right.
Okay, so we don't have any parentheses, we don't have any exponents, but we do have multiplication. So 2 times 6 is 12, 12 plus 3 is 15. All right, so here comes your second lesson. If x is equal to 1/2, what is 8x plus 2 equal? And if y equals 3/4, what is minus 2y plus 1 equal? And if z is equal to 2, what is 8z, z squared plus 4 minus z equal? So this is your opportunity to pause this and work through these equations and then come back and we'll pick it up. All right? Presumably you've paused, presumably you've picked back up. Now we're going to use the substitution principle. So anywhere we see an x, I can put in a 1/2 in this first problem. So we have 8x, so that is 8 times 1/2 plus 2. Remember your order of operations is multiply, divide, then add, subtract. So 8 times 1/2 is 4. Then your order of operations says do your addition, subtraction. 4 plus 2 is 6. On the second one, we have minus 2y. We're going to come up here. So we have minus 2 times y. Y is 3/4 plus 1. All right, remember how to multiply fractions. If you have a whole number, you have to turn it into a fraction. Okay, and then you multiply going across. All right, remember your order of operations. You do your multiplication and division first, then your addition and subtraction. And finally, remember how to multiply and divide negative numbers. A positive times a positive is a positive. A negative times a negative is a positive. And a negative times a positive, and a positive times a negative is a negative. This is a negative, this is a positive, so we're going to have a negative number here. It's going to be minus 2 times 3 is 6 over 4. Bring down your plus 1. Remember how to add fractions. 1 is 1 over 1. And 1 is also equal to 4 over 4. Minus 6 plus 4. So if you had 6 marbles, if you had 4 marbles and I took 6 away, I'd take your 4 marbles, plus you'd owe me 2 more. So you would have minus 2 marbles over 4. Reduce your fraction. 2 goes into 2 once, 2 goes into 4 twice, so you have minus 1/2. That's your answer. And in this last one, substitution principle, we do the substitution first. So 8 times z squared is 2 squared plus 4 minus 2. Because we had 2 z's, so we had to put it in twice. First step is your exponents. 2 times 2 squared is 4. I'm going to come right over here. So 2 squared is 4. So 8 times 4 plus 4 minus 2. Remember, the next step is multiplication division. 8 times 2 is 32 plus 4 minus 2. This you can do in any order. 4 minus 2 is 2. 32 plus 2 is 34. All right, and that ends your first lesson and your second lesson. Congratulations.